Hey, all you cool falcons and birdies. I promise I'll never do that again, but I couldn't resist because every time I start, I feel like I'm saying, Hi, all you cool cats and kittens, and Tiger King's just consumed my life on quarantine. Sorry. So, there you go. All right, so today we are on page 30. Well, it's the same day for me still. You notice I'm not going to change at all, and I don't intend on changing anytime between now and the last video. So disregard the fact that I'm still in the same clothes and my hair looks a hot mess and that there's someone mopping behind me. My house has to be cleaned. Quarantine life. All right, so let's jump into today. We're on page 30. Like I said, this topic isn't super hard. Still stays pretty straightforward up until the next part. Today we're going to talk about how to take polar coordinates and turn them into rectangular coordinates, or the other way around, right? So sometimes we may want to take that polar thing and write it in a coordinate form that's on a rectangular plane. Or sometimes we want to take a rectangular plane and write it into a polar coordinate form. So being able to alternate between the two of them is pretty useful to us. So, a couple things, and this is the part that's going to feel really familiar, like identical to what we've already talked about in terms of the vectors and such, right? So, the polar coordinates we would write in the form of r theta, right? So, r being the radius, theta being the direction angle. And our rectangular coordinates are written in the forms of x, y. Well, we know a couple conversions from when we did our vectors, and here they are. If you're going from polar to rectangular, we knew that if you took the radius and multiplied by the cosine of theta, we got x. And we knew that if you took the radius and multiplied by the sine of theta, you got y. And if you don't quite remember this, it had to do with the fact that on a rectangular coordinate plane, we have a right triangle being made out of all those coordinates, right? If I look over here, if I take this and if I grab some x, y point over x up y, I could turn this into a right triangle that actually goes to the origin, not like that. Try that again. There we go. I could graph these points in a form that the x value is here, the y value is here, so theta is always going to be equal to the radius, or the y over the radius, which ends up being the cosine, and then, or sorry, the x over the r becomes the cosine, and the y over the r becomes the sine value, and then you work that formula out a little bit, and you can rewrite it in these forms that are over here. The rectangular to polar has to do with the fact that tangent is the opposite over the adjacent, so we would do y over x. So the tangent of theta is equal to y over x, and r squared is going to be equal to the Pythagorean theorem, x squared plus y squared equals r squared. So those are where those things come from. So it's important to remember those things and keep those in front of you as you're working through these problems, because it will make them really easy to do. Okay. So the first one we're going to look at is how to convert the polar coordinate to a rectangular coordinate. So example 1, converting polar coordinates to rectangular coordinates. Okay, so convert this polar to its rectangular form. Well, we just talked a little bit about some of those conversion things. So let's start with the x value first. We know that the x value is going to be equal to, and now I am going to look at my notes too just to make sure that I don't jump off track here. The x value is equal to r cosine of theta, right? So I know that x is equal to the radius times the cosine of theta. Well, if this is the polar form, we know that this is the radius and this is theta. So all I have to do to convert this into its rectangular form is plug these things in and start working on it. So I'm going to plug in for r, the square root of 3. And for the cosine of theta, I'm going to plug in cosine of pi over 6. And then we just work some of this out. So thinking about my cosine of pi over 6, that's going to be the cosine of 30 degrees. And I know the cosine at 30 degrees is square root of 3 over 2. And so now I just have this multiplication problem here. Square root of 3 times square root of 3 over 2. And when I do that, I get square root of 9 over 2, which ultimately gives me 3 over 2. So I know the x value is equal to 3 over 2. So now we're going to do something similar for our y value. I know the y value, if we go back and look, is r times the sine of theta. So again, plug in those same things. I know that the radius is square root of 3. I know that theta is pi over 6. And so I'm going to start by figuring out what the sine of pi over 6 is. So the sine of 30, when I think about my unit circle, well, that's going to give me 1/2. Again, if you don't remember, you could use the little hand trick right there. That would be putting down my pointer finger. Putting down my pointer finger, I know that the cosine was square root of 3 over 2 and the sine was 1 over 2. Okay, so if I multiply that out, square root of 3 times 1 is going to give me square root of 3, and then I keep my 2 on the bottom, and that's my y value. So really simple at this point, we know exactly what the rectangular form is, because rectangular is xy, and I know my x is 3/2, and I know my y is square root of 3/2. And so that's my rectangular form. Looking at that in my nicer notes, that's what I had written in my notes. So, pretty straightforward there. I think the other one's a little bit tougher. Going from rectangular to coordinate is definitely rectangular to polar is a little bit tougher. Again, if you want to pause that right there, you can to copy it down. So looking at example 2, same thing. I'll put example 2 up in a second so you can write down the nicer version if you want to just watch me as I do this one. Okay, so the first thing we have to determine is what is my theta. So theta is found by calculating what the... Hold on, let me check that again too. This is new to me too. I just wrote it down. Yeah, theta is using tangent, and then r is using the Pythagorean theorem. So to find my theta, we're going to use the fact that the tangent of theta is equal to the y over the x, which is the opposite over the adjacent. And we'll plug in what we know. I don't know what theta is, right? That's the goal of this right here. But I do know the y value is 1, and the x value is 1. And now remember, when we do inverse tangent, which we're going to have to do here, we have to think about quadrants, and that's really important here. If I were to graph this rectangular point, -1, +1, what is important to remember is that this is going to be in quadrant 2. So when I come down here to figure out what theta is, I'm going to have to take the inverse tangent of both sides. So the inverse tangent of theta is theta. And we'll put tangent inverse over here of 1 over -1, which ultimately just simplifies to -1, right? 1 divided by -1 is -1. So I asked myself, the tangent of -1, when would tangent give me -1 as the answer? Well, I know that tangent gives me 1 at those 45-degree spots, because 45-degree spots have radical 2 over 2 and radical 2 over 2, which divides to make 1. But if it's -1, it means that either the x or the y has to be positive or one has to be negative. They have to have one of each. And that happens in 2 quadrants, quadrant 2 and quadrant 4. So ultimately we wanted it in quadrant 4. So I need the reference angle of 45 degrees in quadrant 2. So which angle would give me 45 degrees here? Well, we know that's going to be, it's pi over 4, pi over 2, 3 pi over 4. So I know theta is 3 pi over 4. So that's my first part, well, technically the second part of the polar coordinate, right? To get my first part, my r, that's where we're going to have to use our r squared equals x squared plus y squared, the Pythagorean theorem. So r squared is equal to, I know my x squared is -1, so I have -1 squared. My y is 1, so I have 1 squared, which ultimately, that -1 squared is going to cancel out and become 1. That 1 squared is also going to give me 1, so r squared is equal to 2. And we'll square root both sides, and I get that r is equal to the square root of 2. And that makes this last step super easy. If I want to now go ahead and convert that into its polar form, all we're going to do is put the radius and the direction angle. The radius is the square root of 2. My direction angle is 3 pi over 4. And that would be the polar form, well, one of the polar forms, right? We said polar forms can be rewritten in a lot of ways. I could have written this also as -pi over 2 and -pi over 4. I could have written this as pi over 2 and 11 pi over 4. It looks kind of similar to yesterday's example, right? It's the same numbers. So there's multiple ways you can do it, but this is the kind of the base way that we would start off with. Let me put up that example. That was the last example for the notes here. And that's a little bit nicer of a version of how I did it. So again, pretty straightforward. This is not a super hard topic, which is nice. A little bit of practice and you'll get it. You definitely want to practice it a couple times, go through it a few times. Make sure you feel comfortable with it, but the whole math behind it isn't super hard. So Good luck. Let me know what help I can give you, and I'll talk to you all later. Bye.